In this lesson, we're going to look at some more examples of double displacement reactions. So as a review, remember that double displacement reactions involve the exchange of cations between two ionic compounds. So this is represented generally as AX plus BY, creating BX plus AY. So A and B have switched their partners. An example is when sodium chloride reacts with silver nitrate in aqueous solution. It results in the formation of a precipitate of silver chloride and aqueous sodium nitrate. So in this reaction, the sodium and the silver have switched places. And after that happens, the silver chloride is no longer soluble and it comes out of solution as a precipitate. So also recall that you can tell that a double displacement reaction has occurred if one of the following three things happens. So the first is when a precipitate or a solid is formed, like in the example we just went through. The second, water is produced. The third, a gas is produced. So we have a previous lesson which covers the formation of precipitates. So today we're going to look at the reactions where water is produced or where a gas is produced. So starting with double displacement reactions that form water. These are a special reaction called a neutralization reaction. A neutralization reaction involves the reaction of an acid with a base to form water and a salt, what's commonly referred to as a salt. That's just an ionic compound. So in general, they can be written as acid plus base makes salt plus water. So here's an example. So H2SO4 is sulfuric acid, or we've been naming it as hydrogen sulfate. And it's reacting with potassium hydroxide, which is a base because of that OH, the hydroxide. So the potassium and the hydrogen are going to switch places in the double displacement reaction. So we're going to get potassium sulfate, and then we're going to get hydrogen ions combining with the hydroxide ions to create water. Okay, so the key thing there is that the water forms when the hydrogen ions from the acid combine with the hydroxide ions from the base. So let's look at some examples. So determine the products that form when hydrochloric acid or hydrogen chloride reacts with potassium hydroxide. So we need to figure out the chemical formulas for hydrogen chloride and potassium hydroxide. So hydrogen chloride is with the hydrogen ion and the chloride ion. Crossover, we get HCl. And like with other double displacement reactions and single displacement reactions, your reactants will be aqueous. So this reacts with potassium hydroxide, KOH. So the K and the H are going to switch partners. So the H is going to be with the OH. So that's HOH, but we commonly refer to that as water, and we write it as H2O, which is a pure liquid. And then the KCl have come together to make an ionic compound or a salt. So that's one reaction. Another example, barium hydroxide reacts with acetic acid, which is also hydrogen acetate. So here's barium hydroxide. Crossover, we get BaOH2, aqueous. Hydrogen acetate, crossover, HCH3COO, also aqueous. So the hydrogen and the barium are going to switch spots. Barium combines with the acetate ion to make barium acetate, which you confirm with your solubility table is aqueous. And then the H and the OH combine to make water, H2O liquid. Okay, so those are the neutralization reactions that create water. And then don't forget at the end that you need to balance, right? So in our last example here, we need to balance by putting a 2 out front of acetic acid and a 2 out front of water. So neutralization reactions are important in everyday life for treating an acid or base spill or for treating acid indigestion. So when you have a solution with a high pH, which means it's basic, if you add an acid, it can make the solution neutral, and this will reduce the harmful effects of the base. Likewise, if you have a solution with a low pH that's acidic, you can add a base to make the solution neutral and reduce the harmful effects of the acid. Okay, so I mentioned acid or base spills. So if you happen to spill a lot of acid, you would put base on it, which would neutralize it and just create water and a salt, which you could then carefully clean up. The other example of acid indigestion, so when you take an antacid, what you're doing is neutralizing the excess acid in your stomach. So those antacids are basic, they have a higher pH, and that neutralizes the acid in the stomach that's causing you the indigestion. Now we'll look at double displacement reactions that form a gas. What happens here is that a double displacement reaction occurs, and then the gas isn't produced immediately, but the double displacement reaction is then followed by a decomposition reaction of one of the products, which then creates also water and a gas. So you need to keep your eye out for two products that will rapidly decompose to form water and a gas. So when you see these products from a double displacement reaction, you need to remember that they're then going to decompose. So the first one is carbonic acid, or we've been referring to it so far as hydrogen carbonate. So when hydrogen carbonate forms from a double displacement reaction, it's then going to decompose into water and carbon dioxide. And that reaction looks like that. H2CO3 breaks down into water and CO2. So you have to keep a lookout for that H2CO3. The other chemical you need to keep a lookout for is ammonium hydroxide. So it decomposes to form water and ammonia gas, and that looks like this. NH4OH breaks down into H2O and NH3 gas. So let's look at an example. Determine the products that form when sodium carbonate and hydrogen chloride react and write a balanced chemical equation. So sodium carbonate, we figure out like this using our crossover, Na2CO3, and hydrogen chloride looks like that. So first we're going to carry out a double displacement reaction. So the hydrogen and the sodium are going to switch partners. So sodium's now with chlorine, which is aqueous, and now the hydrogen is with the carbonate ion, which is also aqueous. So now at this point you need to recognize that H2CO3, because otherwise you're going to think that no reaction has happened because you have two aqueous products. However, you see H2CO3, a light's going to go off in your head and you're going to say, oh yeah, that's one of those ones that has to decompose. You can also balance at this point, or you can go forward with the decomposition. So H2CO3 is going to decompose. It's going to be converted into water and carbon dioxide. So you take the water and the carbon dioxide and you replace the H2CO3 with those two products instead. So overall, the reaction becomes Na2CO3 plus 2HCl makes 2 NaCl, and then instead of H2CO3, we have plus water plus carbon dioxide. So now when you look at those products, you see the formation of a gas and also water, telling you that the reaction has indeed occurred. Okay, let's look at one more example. Determine the products that form when ammonium chloride and sodium hydroxide react and write a balanced chemical equation. So ammonium chloride looks like this, NH4Cl. Sodium hydroxide looks like that. So now we're going to carry out the double displacement. We're going to switch the spots of sodium and ammonium. So we're going to have sodium chloride and then ammonium hydroxide. Again, you get to this point, you might think, oh, there's no reaction. But you have to remember that that ammonium hydroxide is going to decompose. And the decomposition reaction for that is that it decomposes into water and ammonia gas, NH3. So we take the water and the NH3 and replace the ammonium hydroxide in the products. So overall, we've got ammonium chloride plus sodium hydroxide, making sodium chloride plus water plus ammonia, NH3 gas. So those are the types of double displacement reactions that you're going to be asked to predict products for. So the ones from the previous lesson with the precipitate, and these new ones, the neutralization reactions that create water, and the double displacement reactions that are followed by decomposition to produce a gas.